Hello everyone, I am Professor Anis Vora and I welcome you all in this video lecture. In this video lecture, we will study about full wave rectifier, and in case of full wave rectifier, we will study bridge rectifier. A rectifier is a device with the help of which we can convert AC supply into DC supply. In single phase rectifier, we have two configurations. One is half wave rectifier and one is full wave rectifier. In case of full wave rectifier, again we have two configurations. One is a center tapped transformer and one is bridge rectifier. In this video lecture, we will study about a bridge rectifier. First of all, let us see the circuit diagram. We use one transformer. Transformer is used to step up or step down the input AC supply voltage as per our need of the DC voltage. At the primary of the transformer, 230 volt AC single phase supply is connected. On the secondary side, we connect our diodes. In case of bridge rectifier, center tap transformer is not required, but we require 4 numbers of diode. We do the connection of the diodes in such a way that it resembles like a Western bridge, and that is why the name bridge rectifier is given. Now the connection. We connect anode of D1 with the cathode of D4, and same way we connect anode of D2 with the cathode of D3. It is connected to the AC supply, that is secondary of the transformer. Cathode of D1 and D2, that is connected together, that is common cathode, and anode of D3 and D4 is connected together, and that is known as a common anode. And this both the point common cathode and common anode is connected across the load for the DC supply. Common cathode is a positive terminal and common anode is a negative terminal. So it is connected to the load for the DC supply. We have load resistance and we have positive and negative terminal. Positive terminal is connected to the common cathode and the negative terminal is connected to the common anode. So this is our circuit diagram, and now let us see the working of the circuit diagram. In case of positive half cycle, we have point A is more positive compared to point B. In this condition, diode D1 as well as diode D3, both the diode are forward biased. They start conduction. The PN junction of diode D1 and D3 offers a very low resistance to the AC supply, and they allow current to pass from anode to cathode. At the same time, diode D2 and D4 both are reversed bias because point B is negative compared to point A. So diode D2 and D4 do not conduct during positive half cycle. So current start from point A, it passes from anode to cathode of diode D1, then it goes to the positive terminal of the load resistance, that is X. It travels from X to Y. Return path is through the diode D3, anode to cathode of D3, and then it return back to point B, and at last it end at point A. So this is the current path during positive half cycle, and current through the load resistance is from X to Y, that is positive to negative. The path of the current point A to D1 to X to Y, then D3, then at the terminal B, and then at last it ends at point A. So this is complete closed path for the current during positive half cycle. The flow of current in the load resistance, that is a unit direction, and that is from point X to point Y, positive terminal to negative terminal. Same way during negative half cycle. In case of negative half cycle, point B is more positive compared to point A, and in that condition diode D2 and D4 both are forward biased, they start conduction, and at the same time D1 and D3 both the diode are reversed biased, so they do not allow to pass the current from anode to cathode. Now let us see the path of conduction during negative half cycle. It starts from point B. D2 and D4 both are forward biased, so it passed through the D2 anode to cathode. Then it travels from point X to point Y, that is positive terminal to negative terminal, through the load resistance. It returns back through the diode D4 to the point A, and at last it ends at point B. Now we can see that in the load resistance, the flow of current, that is from positive terminal to negative terminal, point X to point Y. So we can see that in both the condition, either in positive half cycle or negative half cycle of the AC supply, the flow of current in the load resistance remain unidirectional, and that is why we can say that we have converted AC supply to the DC supply. The path of conduction during negative half cycle, that is it start from point B to D2, then X, Y, return back to D4 to A, and at last it make a closed circuit to the point B. Now let us see the waveform. At the input side, as usual, on the x-axis we have taken angular frequency, that is omega t, and on the y-axis we have taken magnitude of the input side AC voltage. We know that it is a sinusoidal voltage, and the cycle, that is from 0 to pi to 2 pi. Up to 2 pi it completes one cycle, then up to 4 pi it completes a second cycle, and so on. Now let us see the output waveform. We know that in case of a full rectifier, during positive half cycle as well as during negative half cycle, a rectification process takes place, but through the load, the flow of current is a unidirectional. We have taken magnitude of the current, that is DC current, on the y-axis at the output side. So we are preparing a waveform for the current, DC current, at the output side. It is a rectified but pulsating. It is a unidirectional. During 0 to pi, we have positive half cycle. So we know that diode D1 and D3 will conduct. between 2 pi to 3 pi, again we have positive cycle, so diode D1 and D3 will conduct. Same way between 4 pi and 5 pi, again D1 and D3 diode conduct. And during negative half cycle, that is pi to 2 pi and 3 pi to 4 pi, diode D2 and D4 conduct. And same way for 3 pi to 4 pi. So it is a continuous rectification process. During both the cycle, conduction take place. In the load, we have unidirectional current. We get output voltage, that is DC voltage, across the load resistance, unidirectional. So we can say that we have converted our AC supply into DC supply. We have certain advantage of bridge rectifier. The most important advantage, that is a center tape transformer, is not required. Peak inverse voltage across the diode is half than that of the full wave rectifier with the center tapping. Output voltage is double than that of full wave rectifier with center tapping for the same secondary voltage. In case of a center tape transformer, we know that we have two secondary, so voltage is equally divided in two secondaries. At the same time, we have certain disadvantages also. 4 number of diodes are required. At a time, 2 diodes always conduct during positive half cycle as well as during negative half cycle. 2 diodes are always conducting, so voltage drop across the diode is comparatively more. In low voltage application, it really matters. Thank you for watching my video. Keep watching. Thank you very much.